In this video, we're going to solve this logarithmic equation that involves different bases here. So it has a base 2, has a base 4, and we're going to solve this several ways. And I just want to show you some of the properties of logs. And of course, several of these you'll use when solving logarithmic equations. Hopefully you've seen these before. Got your definition of log here. Log x to base a equals y means x is equal to a to the y. You got these over here. You can pause the video and look at these if you haven't seen these before, but hopefully you have. And these two here, change of base formula. This one, of course, you can use to change the base. So you have log of m to base a. This becomes log of m over log of a. And you pick the base here. Now if you're just finding a numerical approximation, m is a number, then you would probably use natural log or log to base 10, because that's what you have on your calculator. At least most of them will have it. And this one, the last one here, the log of x to base a equals the log of x to the n, a to the n. This one I proved in another video, so that's one you can also use. So for the first method, I'm just going to use the natural log. So I'm going to change this to base e. So this is going to become 2. And then I got log of x to base 2. That'll become natural log, using the change of base formula. Natural log of x over the natural log of whatever the base is here. And then it's minus, same thing for this one. It's the natural log of the x and the natural log of the base here, which is 4. And that's equal to 6. And then here's how I'm going to use one of the properties. This is in the denominator here, natural log of 4, and that's the same thing as 2 to the second. So think of 4 as 2 squared. The 2 can come out here in the front. And you got that. So I just mark this out. This is what I have. So I'm going to multiply through by 2 natural log of 2. So it's going to cancel for this one here. It's going to be gone. So this is going to be minus ln of x. And over here, the ln of 2 and the ln of 2 will cancel. I'll have 2 here, multiplying this 2. So that'll be 4 ln of x. And over here, this is going to equal 2. And then 6 times 2, that'll be 12 ln of 2. So from here, we have 4 minus 4 ln of x minus ln of x. So this becomes 3 ln of x will equal to 12 ln of 2. And then divide both sides by 3, and then go up here. And I get ln of x will equal to 4. 3 into 12 is 4 ln of 2. And then using the definition of log, I have the log of some value, in this case x, is equal to a value here. That's actually your log for this. So this would equal to, again, I'm just using the definition of log. You have the log of a number, in this case x, equal to a number. Then this value x will be whatever the base is here. This is e taken to this power. So this will be 4 ln of 2. And then we evaluate this. So this is e to this exponent here. So another way I can write this would be e, and I can put the ln of 2 here, and that'll be taken to the 4th power. Just applying laws of exponents here, because you have a power to a power, you multiply the exponents, that just gives me this right here. But now in the parentheses, because I have e to a power of ln of 2, this is e and this is e. So again, property, logs tells me this, that e, and this is e here, this is ln, natural log, this is just going to be 2. And that's to the 4th power. 2 to the 4th is 16. And let's check it out. Let's put a 16 here. So the log of 16 the log of 16 to base 2 is 4, because 2 to the 4th, as we saw here, is 16. So this is 4 times 2, this will be 8, minus, I put a 16 here then, the log of 16 to base 4, in this case is 2, because 4 squared is 16. So this will be 2, 8 minus 2 is 6. So this is one way to do it. And again, the answer to this one, of course, is 16. Just checked it. There it is. Now this is basically the same sort of thing, except now I'm going to use base 2. So I want to change everything to base 2. Well, this one already has base 2 there, so let's just put 2 log to base 2 of x minus. And this one has base 4, so let's just do this. Using the change of base formula here, it'll be the log of x base 2, and that's going to be over the log of this base here, which is 4 to base 2. Now we have both expressions to base 2. And that's still going to equal to 6. Okay, log of 4 to base 2, that's 2. Because 2 squared is 4. And then I just multiply through by 2. That'll give me a 4 over here. It'll be the log of x to base 2. This will be minus. And this 2 here will cancel because I'm multiplying by 2. So this would just give me the log of x to base 2 equals 6. So again, I had 4 log x base 2 minus log x to base 2. So this will give me just 3 log of x to base 2. And of course I multiply this side also by 2 here. So this is actually 12 here. 2 times 6 is 12. So this is going to equal to 12. Divide through by 3. I get the log of x to base 2. Then 3 into 12 is 4. And here I just use the definition of log. I got the log of x to base 2 equals to 4. Means that x has to equal to whatever this base is, of course 2, taken to this power, that's 4. 2 to the 4th is 16. That's another way to work it, using a different base. But it's the same idea, same formula. So again, I get 16. Now the next method I'm going to use here, now I'm going to change everything to base 4. This is base 4. I'll go over here. So this will be 2. This will be the log. Again, here I'm using the change of base formula. Base 4. And that's over the log. Again, same base I'm using is 4 to the base of the original one, which is 2. You got that. Minus, okay, this one already has the base 4. So when you're solving an equation, a log equation, and the base is the same throughout, and of course you can still use those other properties of logs to solve the equation. And here, first we're changing the base, and then we still can apply some of those properties that I just went over. So let's simplify this here. Log of 2 to base 4 is what? Well, it's saying 2 is equal to 4 to what power? That's your definition. 2 equals to 4 to what power? 4 to what power will give me 2? Well, 1/2. Because the square root of 4 is 2. So this would be 1/2 here. So this is gone. Multiply through by 2 here to get rid of this fraction, and 2 up here. So this will cancel, and then this will be come up 4. This will be a 4 here. And then I got 4 log x to base 4 minus log x to base 4. This will give me 3 log x to base 4. This will be 6 here. Divide through by 3. So dividing by 3, I get the log of x to base 4 is equal to 2. 3 into 6. And now I have log of x to base 4 equal to 2, using the change of base, or using the definition of log, I should say. X is equal to 4 squared. which is equal to 16. And of course, if you've already checked it, that's your solution using that approach. And another method, using the second formula that I mentioned about change of base, or the log of x to base a, would be the same thing as the log of x to the n to base 2 to the n. So if I square this and square this, those are still the same. And of course, that'll change the base. Notice here, this will go from 2 to 4. So this will be a 4. This will be a 2. So square this, I get a 4, and we square this. Okay. So now, let's do this. Here I'm going to use a property of logs. This is a coefficient. I can bring this over here as a power. This becomes 2 squared. So this gives me base 4 here. And this will be x to the 4th minus log of x to base 4 equal to 6. Now another property of the log I'm going to use here. I have the difference of 2 logs and they have the same base. So keep that in mind. Some of these properties you can't use unless they have the same base. So here I can write this as the log. And you have a difference of logs for the same base. You can write this as a fraction. So this can be x to the 4th over x base 4 equals 6. Now remember that for logs, you can't take the log of 0. So I know that this x here is not 0. So I can divide through there. And I can write this as the log base 4 of x cubed equal to 6. X can never be 0 for this, in this particular case, for logs. So I get this log of x to the 3rd to base 4 equal to 6. So again, definition of log. This tells me that x to the 3rd should equal to 4. This base taken to that power to the 6th power. And here just take, instead of going and calculating this, I'm just going to say, let's take the cube root of both sides. So the cube root of x to the 3rd is x. And cube root of this side, I can write it as a power 1/3. Multiply the exponents there. 1/3 times 6 is 2. So I get x is equal to 4 squared, or 16. And that's the same answer we got in the other methods. And there's at least one more that I can think of, but you can have your pick here as to which one you want. Now the thing with it, the problem with this one here, this one's not always going to work, because taking this to a power, and a power might not give to you this. Say this is 5. Say this is 5 here. Get a little bit complicated to get the same base here. But you have the other methods. Thanks for watching. We'll see you next time.